Welcome to You Can Do It Math. Today we're doing the May-June 2022 paper 21 extended. Let's go. Question 1, write down a prime number. Let's remember the prime numbers. The first prime number is 2 and that's the only even prime number. Then it goes 3, 5, 7, etc. Any number that only has two factors, the number itself and 1. So a number between 30 and 40, as I said, won't be even. First one that springs to mind is 31. 31 can only be divided by 1 and 31 itself. Not 33 can be divided by 3. Not 35 can be divided by 5. 37 is another one. 37 can only be divided by 1 and 37. 39 we can divide that by 3 and 13. Question 2, we need a calculator, and then we can simply put this into our calculator. So we start with 4, I'll switch it on, 4 to the power of, that button there, x power, 5, use the arrows to move down, minus 5 to the power of 4 equal 399. Quick and straightforward. Question 3, Jason starts a run at 10:05 and finishes at 1:02 in the afternoon. Workout time Jason takes to complete the run. Okay, my favorite method here is the leapfrog method. So we start at 10:05. Let's jump to the nearest hour. That will be 11 o'clock. That will be 55 minutes to get there. Then from 11 o'clock, we go to 12 o'clock, and then we go to 1 o'clock in the afternoon. Okay, so this is where PM starts. So that's another 2 hours, and then we need to jump another 2 minutes to get 2 minutes past. Okay, so we add that all up. That will give us 2 hours, 57 minutes. Question 4, again, nice calculator question. We start by putting in the fraction button, and then we can type it exactly like it is. 1.07, arrows down, 0.45 minus 0.38, and we get the answer 4.2857. 14, and those two dots means we're recurring. Okay, now they wanted to 4 significant figures, which means 1, 2, 3, 4. We're going to cut it off there. But next to the 5, there's a 7, so we're going to round that 5 up to a 6. Final answer, 4.286. Question 5, currency changes some dollars into pounds when the exchange rate for $1 is 1.19. So let's write it down. So 1 pound is $1.19. Now she has the dollars, so let's write that underneath the dollars. Okay, so how do we get from there to there? How do we get from 1.19 to 380.80? And the answer is we have to do that backwards. So we're going to divide. That means we need to times it by 320. So 1.19 times 320 gives us 380 and 80 cents. So we do the same on this side. We times it by 320. Well, that's easy because it's only times by 1. The answer we have is 320 pounds. Question 6. Product means multiply. Okay, prime, we know what's the prime numbers. 2, 3, 5, 7. Factors is everything that divides into 180. There are different methods to do this. There's the factor tree. I'm going to do the fishbone method. So we start by this. We do 180 divided by 2. It's 92 because 2 is the first prime number and it goes into 180. I can divide by 2 again. That will give us 45. What's the next prime number? 3. Okay, you can also divide it by 5, of course, because it's also a prime number. But we divide it by 3, we get 15. We can divide it by 3 again, which gives us 5. And then we can divide it by 5, which gives us 1. Okay, we're not dividing by 1. 1 is not a prime number, and that is the answer. It's 180 equals 2 times 2 times 3 times 3 times 5. Do check your answer, yeah? Let's check that. 2 times 2 times 3 times 3 times 5 equals. Yeah, that is correct. Okay, we can write it like it is there. But if you write it in index form, of course, that's also correct. So 2 squared times 3 squared times 5. Both of these is correct. They didn't say write it in index form, so you can write it either one of these. This way or that way. Of course, you get a mark for showing your factor tree. Question 7, without a calculator, meaning we can't do this. We can't do 3 over 7 minus 2 over 21 and press the equal and have the answer 1/3. Okay, that will get us 0 marks because I used the calculator. Okay, what they want us to do is show every single step. So when adding and subtracting fractions, we need to get the denominators the same. So we're going to take that first fraction and multiply it by 3. So 3 over 7, we multiply the top and the bottom by 3. Because that will give us 9 over 21 minus 2 over 21. Now that the denominators are the same, we can subtract it. That will give us 7 over 21. Simplified, that gives us 1 1/3. Now that I've shown every step, we'll get our marks. Okay, 1 mark for getting equivalent fraction, and then once you have shown all your working out, you do get that mark for the correct answer in its simplest form. Question 8, work out the value of S when A is 0.9 and T is 4. So that means S will equal a half. A is 0.9 and T is 4. T is being squared. So let's put it into a calculator just like that. So we got a half times 0.9 times 4 squared. 36 over 5. Now they don't tell us how they want us to write the answer. Okay, but decimal form is always the best. 7.2. And you got your mark. Now we're rearranging the formula to make T the subject. Now the secret here is always to start as far away from T as possible. If T was a number, first it will be squared, then it will be multiplied by A, and then it will be half. So first we deal with a half, yeah? We take this 2, we multiply it on the other side. So 2 times S is 2S equals, that 1 is 1 times everything, so it can fall away. The next thing is the A, so we divide it by the A, so it's 2S divided by A equals T squared. And the last thing, get rid of the square, and for that we square root. So that means we're going to square root everything, and that is T. Make sure that square root covers everything that's to cover. Okay, you can add a plus and a minus in front, you don't have to. It's just remember when we square a negative number, it also becomes positive. Okay, but that plus and minus is not essential for getting full marks. Question 9, factorization, which means we're making brackets. First, we need to get common factors. So let's break this down into all its factors. 14 is 2 factors is 2 times 7, and then there's an x and a y. So 14xy is 2 times 7 times x times y. 7 is a prime number. Y squared means y times y. Now, if we take the common factors here, they both have 7, and they both have a y. That is what we can take and put in front of the bracket, 7y. Okay, inside the bracket we put what's left. The first term has got a 2 and an x, and the last term is got a y. Final answer. Let's write that down. 7y over 2x minus y. That is completely factorized. If you just factorize out the 7 or just the y, of course that's not completely, you only get 1 mark. Question 10. The next term in the sequence. So first we check what is the term rule here, and as we are subtracting 5 every time. So 2 minus 5, the next term is -3. The nth term then, of course, because we're subtracting 5 each time, is n minus 5, right? No, it's not. Don't believe how many people still write that. Okay, it's not n minus 5, please. All right, the -5, subtracting 5 each time means this is like the -5 times table, which goes -5, -10, -15. You see, we're subtracting 5 every time. 5 times table, -5 times n, so -5n. That's what our nth term rule starts with. Difference here is we're not starting at -5 in this sequence, we're starting with 22. Then instead of -10 we got 17, instead of -15 we got 12, etc. So how do we get from -5 to 22? From -20 to 7, okay, or from -10 to 17? We need to get from here to there. We're gonna add 27 each time. You see, each time you add 27. So that's what we do. We add 27. Shortcut as well. Get the 0th term. Continue your sequence that way. What would be the term before the first term? The term over here would be 27, because 27 minus 5 is 22. That's also how we determine what comes at the back. And we've done it. Question 12. The interior angles of a pentagon. So first of all, what does the interior angles of a pentagon add up to? Okay, there's a formula to determine that, right? Remember, pentagon has got 5 sides. So we take the number of sides, which is 5, subtract 2, times it by 180. Okay, which is 540 degrees. If you ever forget this formula, just draw yourself a little pentagon, yeah, and then check how many triangles fits inside. 3 triangles. Remember, each triangle is 180 degrees. That's why in the end we do 3 times 180. That's where the formula comes from. Okay, so next step is the ratio. 4, 5, 5, 7, 9. That means if one angle is 4 degrees, the next one is 5, the next one is 5, the one is 7, the next one is 9. Okay, so if we add that up, 4 plus 5 plus 5 plus 7 plus 9, what is that, 14? That gives us 30, is it not? 30 degrees. Okay, so the angles in this pentagon, 4, 5, 5, 7, 9 adds up to 30 degrees, but that's impossible because it has to add up to 540 degrees. So we need to increase that ratio. Okay, by how much? By how much 30 fits into 540? So 540 divided by 30, 18. So we need to increase that ratio by 18, which meaning we do multiply each bit of that ratio by 18. They only want to know the largest angle, which will be the one with the largest ratio. So that will be 9 times 18. And there we go. 162 degrees is the largest angle in that pentagon. Question 13. Standard form question. And the first thing we see there, let's put that into a calculator. Okay, the way to put in standard form questions is you press the number, you press this button in the middle, and then you just press the index. And you do the same. The next one, -2, index button, and 98, and equal, and bam, we get a syntax error. Okay, that's not because I've put anything wrong. Okay, let's put a smaller number. Let's put 2 exp 10. So that instead of 100, let's imagine that was 10. minus 2 exp 8. I'm just bring 8 because it's 2 less than 10, just like 98 is 2 less than 100. If I put that in, I get an answer. 1.98 times 10. Let's write that down. So when I actually put in 2 times 10 to the power of 10 minus 2 times 10 to the power of 8, I get 1.98 times 10 to the power of 10, which gets me very close to the actual answer. Okay, but I think they've done it like this because they know if we put really big numbers in there, if that's not 10, it's 100, and if that's not 8, it's 98. Then it gives us syntax error. Numbers must be too big for our calculator. So let's do this without a calculator. All right, let's do this first, right? 2 times 10 to the power of 100 is a 2 with a 0 and another 0 and another 0 and another 0, and this goes on, okay, with 100 zeros in total. So I put 4 zeros, so it means after that there should be another 96 zeros going there all the way. Okay, then the next number is 2, index is 2 smaller. That means it's 2 spaces or 2 spots smaller. So where this one has got 100 zeros, this one's gonna 2 is gonna start here, and it's gonna have 98 zeros. So that meaning if I put 2 zeros here, I still have 96 zeros left. So I've now lined up the place value of those two numbers perfectly. Okay, and what we're doing is we're subtracting them. So let's subtract them, right? So we're going to start with 0 minus 0, 0, 0 minus 0, 0. We're going to do that 96 times. Then we get here. Then we do again 0 minus 0, 0, 0 minus 0, 0. 0 minus 2 is what? Remember from primary school, we need to go borrow. So we borrow 1 here. This becomes a 1. This becomes a 10. We borrow 1 from there. That becomes a 9. This becomes a 10. 10 minus 2 is 8. 9 minus nothing is 9. And 1 minus nothing is that. So we now have 19800, and those zeros continue on for 96 zeros. So that's our answer. A 198 with 98 zeros behind it, because I've got 2 there and there's another 96. So now to write that in standard form, I need to start with the last 0 and count the space, right? So I'm going to count the spaces from the last 0. When I get here, I would have counted 96 zeros, and I had to count another one, 97, 98, 99, 100 spaces. I need to count to put the decimal point behind the 1, because that is what standard form is. Got the decimal point behind the first digit, and I had to move that decimal point 100 spaces, and that's the correct answer. Okay, I hope that makes sense. Question 14. Oh, they love to ask stuff like this. Right, first of all, we're dealing with speed. So where's our triangle? Speed. What is speed? Okay, speed is kilometers per hour. Kilometers being distance, hours being time. So speed is distance divided by time. Okay. So they tell us we got a station. Let's draw ourselves a station. This is a train station, in case you wondered. All right. And this station has a length of 120 meters. Okay. And a train comes and it passes the station in 7 seconds. So first thing we need to notice here is that our speed is kilometers per hour, but we're working in meters and seconds. So we need to change 108 kilometers per hour, that per means divide, to meters per second. So first we change kilometers to meters. Kilo means 1,000. So we're going to take 108 times 1,000. Okay, that means we travel 108,000 meters per hour. Next, we want to change hours to seconds. So how many seconds in an hour? Well, there is 60 seconds in a minute, and there is 60 seconds in an hour. So that gives us a total of 3,600 seconds in an hour. Now, you see that's divide. the hours below the line. So we divide this by 3,600 seconds, and bam, we change it. 108 kilometers per hour is 30 meters per second. That is how fast the train is traveling. So imagine here comes the train. This is the nose of the train, and that's important that we know where this is the nose of the train. And let's make this the back of the train. Okay, it comes, and when it reaches the first edge of the station, we start counting time. And then when the nose reaches the other edge of the station, how much time would have passed? Okay, from there to there. We're traveling 30 meters per second. Okay, and the distance is 120 meters. So we do distance divided by speed. So 120 divided by 30 is 1 second. It travels 30 meters, so 120 meters. It would take it 4 seconds for the nose of the train to go from the one edge of the station to the other edge of the station. Okay, but it didn't take the train 4 seconds to pass. It took it 7 seconds. So that means that 7 seconds is what it took from the nose to reach the edge of the station, and then for the back of the train to leave. Okay, so if this train continues, the back there. Okay, so how much extra time do we have? 3 seconds. 3 seconds we're talking about. So we got 3 seconds, yeah? So that was 7 seconds minus that 4 seconds. So now it's 3 seconds. So we got time. And we have the speed of the train, which is 30. So we have to know the distance, which in this case would be the length of the train. We need to multiply to know the distance. We need the speed times time. And we're working with that extra 3 seconds. So the speed is 30 times the extra 3 seconds it took the whole train to pass. That gives us 90 meters. And that's how long the train is, because there's that 90 meters that made up the extra 3 seconds for the train to pass by. And that is our answer, 90 meters. Now you've done it. Question 15, we want to know what is that little x is an index. Now if we can get the two base numbers the same, you see what, a 4 to the power of x. If we can write 1 over 64 to 4 to the power of something, then x will be equal to that something. So we need to write 1 over 64 as 4 to the power of something. So let's first start with 64. 64 equals 4 to the power of what? So let's quickly, we can do trial and error. 4, let's try 4 cubed. Oh, 64, that was quick. 4 cubed equals 64. So we can write 4 to the power of x equals 1 over 4 cubed. Because 4 cubed is 64. Then we need to remember the next rule of indices. If we got an index, that's an a, as a denominator, we can write it as a negative power like that. That's the same thing. So that means we can write 4 to the power of x as 1 equals 4 to the power of minus 3. Okay, don't believe me? Put it in your calculator. 4 to the power of negative 3. What does that equal? 1 over 64. Brilliant. Now we got the base numbers the same. So this is a 4 and this is a 4. That means that equals that, meaning our answer is minus 3. Question 16. All right, transformations. The first thing we describe the single transformation. Remember, it's a single transformation. So it's not going to be two things. It's going to be one transformation only. Okay, so the first thing we need to notice that the size of the shape has changed. Okay, from T to P it's gotten smaller. So there can only be one transformation, and that's an enlargement. Even though it got smaller, it's an enlargement. So that's the first thing you need to write down, an enlargement, and you got 1 mark. Okay, now I know it's confusing because it looked like it spun around, it looked like it flipped over, and you're tempted to go for a rotation or a reflection, but it said in bold, it says single transformation. So enlargement through and through. Okay. With enlargement, we always got our guidelines to show us what's going on and our center of enlargement. And to find those, we use a ruler and a pencil and we connect the corners with the corner. Let's start with that right angle corner, right? We will connect the right angle corner with the right angle corner of the enlargement. So going from T to P, I'll draw a line like this. Okay. Then we take the next angle above, the bigger of the two acute angles. We connect those. And lastly, the smallest angle in both triangles, we connect those. And if you do this right, you'll see they all converge on a little point there. Mine is slightly off because my angle isn't 100% accurate, but they all converge there on that point there, which is the coordinate 4, 4, and that will be our center of enlargement. So let's write that down. Right, center of enlargement, don't have to write that, is the point 4, 4. And now we've already got 2 marks. Okay. The last thing we need to find is the scale factor. How much has it enlarged? Okay, so first of all, let's write scale factor. Okay, now this has gotten smaller. Okay, we've got smaller, that is a fractional scale factor. Okay, that's not what makes it negative. Negative doesn't make it smaller. Fractions makes it smaller. And you can clearly see that if we look at the height of this triangle, those are 2 squares height. Now the height is 1. It's gotten half the size, so the scale factor is a half. Okay, that fraction saying it got smaller. But we're not finished. It's also on the opposite side of the center of enlargement. Okay, opposed to on the same side of the center of enlargement. Let me show you what this means. If it was just a enlargement of half, scale factor of half, then the triangle would have looked like this. It would have been over here. This is just a rough sketch. That's scale factor of a half. Okay, half the size and half the distance to the center of enlargement. Okay, but that's not what we have here. It is actually on the opposite side of the center of enlargement, which means it flipped over, and that is why this is a negative scale factor. Okay, and that's the final answer. Enlargement, 1 mark. Center, 4, 4, 1 mark. Scale factor, minus a half because it's half the size, and minus because it's on the opposite side of the center of enlargement. Question 17. What a booby trap. Lots of students got made mistakes here, don't get full marks because of one little detail that we've missed. Okay, they give us the formula for the volume of a sphere, and there it is, and that's what we're going to use. And then they give us the volume of a hemisphere. You know what a hemisphere is? That's half a ball. That's it. That's the hemisphere. But the formula I gave us is the whole thing. Okay. So what we're going to have to do is we need to double it. We need to double that 80 so we have the volume of the whole sphere, because that's what the formula refers to. The whole sphere. Well, as the 80 is only half the sphere. Okay, so this is what we're going to have to use. 160. So we put that into the formula. Volume there is, which is 160, equals 4 over 3 pi r cubed. So now to find the radius, we just need to solve that. Okay, first thing we're going to do, this is divided by 3, so we multiply the 3. So it's 3 times 160, and then there's a 4 above, so this is 4 times everything, so we divide it by 4. Okay, that will give us pi r cubed. So 3 times 160 divided by 4, bam, 120. So 120 equals pi r cubed. Next thing, we get rid of that pi, we divide it on the other side. I'm not going to do it yet because it's going to give me a bunch of decimals. Okay, last thing we want to do is move that cubed, which will give us cube root of 120 over pi, which will give us r. So that means r equals, let's do that. Okay, we press shift, that got cube root, fraction, 120 over pi equal, and there's the answer, 3.367, etc. Rounded to three significant figures is 3.37. Okay, always pay attention to details, hemisphere and sphere. Question 18, circle theorems. All right, let's go slowly, look at every detail. Right, first of all, it says A, B, C, D are points on a circle. A, B, C, D. You see that all on the circumference of a circle. Immediately need to make you think about this one. Okay, cyclic quadrilateral. All the points are on the circle, and a cyclic quadrilateral, remember, opposite angles equals to 180. So immediately remember that. So what can we tell from that? If this one is 60, the opposite angle there would be 180 minus 60, 120. That is what information we can deduct from the first point of information. Next one, TU is a tangent. Let's think about the single tangent theorems. Okay, we got this one here. The angle between a radius and a tangent is 90 degrees. We don't have any radiuses in this one. What else is there? There's the alternate segment theorem. This one over here, which means the angle between a chord and a tangent is equal to the opposite angle. Right, short alternate segment theorem, whatever else for it. Okay, so that's 60, that's 60, this is 70, that is 70. So look at this here. We got this triangle. Let me mark it, DACD. So this angle here, 38, will be equal to the opposite interior angle, 38. And that's what we can deduct from that piece of information. Okay. Next is they tell us that DA is parallel to CB. Okay, so immediately they talk about parallel angles. We think about corresponding F angles, alternate Z angles, and co-interior angles is 180. So looking here, I can immediately spot something. Let's mark that. If we go like this, there, what we call that, a Z angle. So if this is 38, this one's 38, okay? Or rather, let's use the correct term, not Z, but alternate angles. Okay, so what does it actually want? Okay, because what we've just done now is we've deducted what information we have from the information they've given us. We haven't answered the question yet, or have we? Find the value of x. We've done that already. X equals 38 degrees. All right, check carefully. Did they ask for a reason? No. So we can just slot it in. Brilliant. 1 mark already. Find the value of y. Now look at that. We already got a lot of information written down there. So to find y in the end, we just need to do angles in a triangle. Equals 180. So that's 180 minus, go away, 180 minus the 120 and the 38, which will give us 22 degrees. And we've done it. Found it all by just looking very carefully at the information they've given. Question 19. Let's look at all the information carefully. In the diagram, AB is parallel to PQ. AB is parallel to PQ. So again, we're going to look for either corresponding F angles, alternate Z angles, or co-interior angles. Keep that in mind. AQ and PB intersect at X. That means AX, the length of this line, and this line is the same. Complete the following statements. So we're looking at triangle ABX. the one at the top, and triangle QPX, the one at the bottom. Okay, and they tell us that what they've already told us again, that AX equals to XQ, and that's given, right? And those are two sides. Right, next one. What do they tell us next? They tell us angle BAX, let's mark that, angle BAX, which is this angle here, equals angle, what angle does that equal to? Okay, just think about this. Have we used the parallel sides yet? No. So if we go down here, what do we have there? We've got a Z. So angle equal this angle here. And what do we call it? We call it angle PQX. Angle PQX or QXP. Okay, it doesn't matter which way you put the P and the X as long as the Q is in the middle. And what's the reason? Z angles. No, not Z angles. Never write Z angles. Never. You always write the proper reason, alternate angles. Right. Let's declutter. Next one, angle AXB. So going from A to X to B, that's this angle here, equals what other angle? Okay, and here we need to think about this angle here, that one here. Of course, they are equal, and this is angle, just take that away, angle PXQ. PX. Say it right. PXQ. Or QXP. Again, as long as the X is in the middle there. And the reason here, if you remember this, angles, call it X angles, but the correct word here is opposite angles. Okay. Furrow correct answer is vertically, but that's not essential to get full marks. Opposite angles. Excellent. So what we were doing here all along is proving congruence. Okay, if you remember proving congruence, there is certain criteria. You either have to prove all the sides is the same, that's side, side, side. You can prove there's a right angle, a hypotenuse, and a side. You can prove one angle and two sides, or in this case, they are congruent because we got two angles and a side. What is important here is that that side, which is this one here, lies between the two angles. Okay, included side, so that is congruent because of angle, side, angle. Therefore, that means that px, what is px, is equal to what? Now, because they're congruent, all the corresponding sides are the same, so px will be the same as this side here, which is bx. Or xb, like on the mark scheme. Now we got it all correct. Well done. Question 20, speed time graph we have here. And first of all, they ask for the deceleration. Remember, in a speed time graph, the deceleration here is equal to the gradient. Now, the gradient is always the rise. The rise here from 0 to 12, so that's 12, over the run, which is the distance here between 16 and 24 is 8. All right, or in other words, looking at the units, we've got 12 meters per second over 8 seconds. So what would that give us? 12 divided by 8, not 2, 12 divided by 8, 1.5, and can you see that meters per second square? Because we did meters per second divided by seconds. So just looking at the units, we can check if we're doing it right. Then 20b, the total distance traveled. Now remember, in a speed time graph, the total distance is the area under the bar. So if we travel for 16 seconds at 12 meters per second, the total distance will be 12 times 16. To that, we need to add the area of this triangle. So remember, the height is 12, the width is 8, but because it's a triangle, we need to half it. So it's half of 12 times 8. So let's do that. First, 12 times 16 plus a half of 12 times 8. Bam, 240 meters. And we've done it. Just make sure your zeros looks like a 0 and not a 6. Question 21, factorizing. It's a bit of an awkward one, but if we split this into two parts, it might become a little bit easier. So let's do it like this. Put a bracket there and put a bracket there. Is that what we really want? Let's try that. Because here we can factor out an a. So let's see what it looks like. So we got 1 minus q. Factorize out that a. Put it in front of the bracket. Remember, if I take an a away from here, I can't put nothing. I need to put something there. So put a 1 plus q. Okay, because when we multiply out these brackets, we need to get our original answer. So minus a times 1 will give you minus a. And minus 1 times q will not give me plus aq. That will give me minus aq. So the moment I take that a there and leave the minus there, it means this needs to be a negative. So let's just do this again to make things clear. Okay, so we're not confused. All right. So first of all, here, imagine there's a 1 there. 1 times 1 is 1. 1 times minus q is minus q. That's correct. Then here, minus a times 1 gives me minus 1a. That's right. And minus a, two negatives makes a positive, and a times q is aq. See, that is all still the same. I've written what's above, factorized. Once we've done that, we can now see, you see this whole bracket and this whole bracket, we can factorize it out. So that will become 1 minus q. And what is left is this 1 here at the front of the bracket and this minus a. See, and that's the correct final answer. Bit of an awkward one, I know. But if you just get enough practice in, do enough papers with me, you can do it. Question 22, indices again. Now remember, everything in that bracket is to the power of 2/3. So we can rewrite it like this, 216 to the power of 2/3. Y, which is to the power of 216 to the power, so a power to a power, we multiply it together. All right, so first over here, 216 to the power of 2/3. 216 to the power of, put a fraction in, 2/3. Bam, 36. Got it. Okay. You want to know why it's 36? Because when we've got a fractional power, it's the same as a root. So we can also write that like this. Okay, which is the same answer. You want to see? Let me show you. So that's the same as cube root 216 squared 36. Okay, hang it in your calculator. Next is this part. We just need to multiply that together. 216 times 2/3. That means y is the power of 144. And that's it. Done it. Save time. Get 2 marks nice and quickly. Question 23. We got x squared plus 8x plus 10 and write it in the completed square form. So let's do that. So we're going to start making the brackets with the square. Then to get the p, we need to take the second term, the 8, and half it. So half of 8 is 4. Okay, and don't drop away that plus 10. Okay, now remember, when we multiply out that bracket, you don't have to do this, just to keep you up to date what's going on. If we multiply this brackets, remember, this means x plus 4, x plus 4. Okay, if we were going to multiply out the brackets, we'll go x times x is x squared. It gives us that x squared, great. We'll do x times 4 is 4x, and 4 times x is 4x, which together gives us the 8x. And the plus 10 is there at the back. See, it's hanging around, so we got that. But we also have to do 4 times 4 is 16. And there's no 16 up there. That's why when we complete the square, we need to take that 4, square it, and subtract it at the back. So that 16 will cancel out this 16 at the end. And we'll have exactly what we got in the question. Okay, so we've done that now. We've completed the square. Okay, with lots of practice, you'll get really quick at this. And then all we need to do is simplify it a bit. We got the x plus 4 stays the same. 10 minus 16 is minus 6. Okay, so the p, there's the p, that is 4. And the q, there is minus 6. Okay, little bonus, by the way, yeah? This will give us the turning point, granted that we change one sign. Let's look at the graph. This is the graph of x squared plus 8x plus 10, the one they gave us. Turning point down here, look at it, minus 4, minus 6. So if we look at our answer here, we just need to change the p-value to a negative, and that gives us the turning point. Okay, which they often like to ask us, but of course they didn't this time. Okay, so the answer is just 4 minus 6. Next one is solve this thing. So you see, this is all the same as they've given us before. Only thing they've changed now is they set it equal to 30. We could say that is y. Y equals x squared. Because this is what I've done here. I've drawn the graph. Let's go back here. I've drawn the graph of y equals x squared plus 8x plus 10. If we draw then where y equals 30, because that's what we wanted, we'll have a line that crosses our graph at 30, and bam, there and there. They want the two x values. So there was the answers, 2 and minus 10, because that's what they want here. They want to know what is x. See, so I already got the answers using Desmos, but you don't have Desmos in the exam, so you need to do this using algebra. Okay, quadratic equation, what we have here. Let's first of all set it equal to 0. So we subtract the 30 from the other side. That will give us x squared plus 8x. 10 minus 30 is minus 20 equals 0. Okay, this is where we factorize to get those two answers, so 2 brackets. I mean, you can use the quadratic formula, but this one is not too hard to factorize. We think about 2 numbers that we multiply together to give us minus 20. So let's think about, for example, 4 times 5. That will give us 20. We want minus 20, so one of them has to be negative. Okay, but if we add them together, we'll get 1. And even if we change the minus to the 5, we'll get minus 1. So 4 and 5 doesn't work. Let's think of other 2 numbers where we multiply together to give us minus 20. And what springs to mind here, of course, is 2 times 10. 2 times 2 gives us 20. You see that 8 there is positive. So it's always better to keep the bigger number positive. Let's make the smaller one negative, because then if we add them together, minus 2 plus 10, we get the positive 8 we've been looking for. And that's what we want. Multiply together, we get minus 20. Add them together, we get the positive 8. And that means we got the two answers. All right. What is left to do then is set each bracket equal to 0. So that means x minus 2 equals 0. So that means x equals 2. And x plus 10 equals 0. That means x equals minus 10. We got two answers there. Exactly like I showed you at the beginning. Remember? 2 minus 10, where the line y equals 30 will cross our graph. And you've done it. Question 24 is Pythagoras in 3 dimensions. Okay, why do I say that? Well, if we had a cuboid and we want to know the diagonal, which goes from one corner to the other, we would have had to divide it into a triangle going like that, see, and maybe another triangle at the base here, and then we would have had to do Pythagoras twice, meaning if this is 24, that is 12, that is 8, we will have to do to find the bottom diagonal. Let's call this x. So it will be x equals Pythagoras 24 squared plus 12 squared. That will give us x. Then we have to take x, and to find this one, let's call this d for the diagonal. To find d, we need to take the square root of x squared plus 8 squared. And we get the answer. I'm already basically there. Okay. But there's a lot quicker way. Instead of doing all that jazz, just remember this. To find any diagonal, let's call it D for diagonal, we can do 3D Pythagoras simply by doing it all at once. Doing 24 squared plus 12 squared plus 8 squared. Straight away will give us the answer. So let's do that. 24 squared plus 12 squared plus 8 squared. Bam. 28. We got the answer. Okay. Remember that. Diagonal of a cuboid, 3D Pythagoras. That's how we do it. Question 25 can be confusing. Let's do this slowly. First of all, it says W is proportional. So we write W. This is the proportion sign to the square root, not the square root of y. Okay. We can change that into an equation by putting in the constant, okay, the constant of the proportion, the ratio. Okay, excellent. Then for the next line, it tells us y is inversely proportional, so we put it like this, 1 over 2x. So we can write it as an equation by putting in the constant k over there. Now I've written those two first lines into mathematical equations we can work with. Okay, now next step, let's use this information we have here. We got W is 8 and the Y is 16. Let's put that into this first equation. W is 8 and Y is 16. Alright, square root of 16 of course is 4. So that means 8 divided by 4, K equals 2. So now I can write this equation here complete. W equals twice the square root of y. Okay. Looking good. Next one, we can write this equation. We got x and y. So let's do that. Y is 16 k, x is 4. 4 times 16, of course. What is that? 84, 64. That's what I said, isn't it? So k equals 64. So that means y equals k over, no, that's not, we just worked out k. 64 over x. Last step, it says find w in terms of x. So well, we got w here, we got it in terms of y, but we got y is 64 over x. So we just need to substitute this for the y. Let's have a go. So that means w equals 2 square root, instead of y, we put 64 over x. We can rewrite that as 2 square root 64 over x. Square root 64, of course, is 8. Oh, square root x. Right, so that means w equals 2 times square root 64 is 8 over square root x. We can multiply that 2 and the 8 together. Final answer, 16 over square root x. Okay, and you've done it. It's all possible through practice. Question 26, vectors. As always, take it slow, pay attention to detail, and we can do it. First of all, the diagram shows triangle OAB and parallelogram OALK. Remember, with all parallelograms, there is information there. Opposite sides of a parallelogram are equal and parallel, of course. That means if OA equals to A, KL equals to A. Okay, piece of information we get from the first line. The position vector of A is A, so being from O to A is A, we can see that. The position vector of B is B, well, we can see that. K is the point on AB, so that AK is in the ratio 1 to 2. So you can see that whole line AB has been divided into 3 parts. AK is a third, and KB is 2/3. That is what we can get from that ratio. Find the position vector of L. So meaning going from O, which is the origin, to L, which is over there. Okay, we need to pick a path. And the path I'm going to pick, let's put this into a nice color. Okay, is this path. Meaning position vector OL equals and KL. Now, great news, we already got KL. KL is A. So we got that. KL is A, but we don't have the rest. Okay. Right. So, what do we need? We need to find OK. So that would be my next step. Let's use a different color for that one. Okay. So first of all, I want to find OK. Okay. There are 2 ways. We can go up to B, or we can go across to A. I'm going to do that. So to get OK, I'm going to go across here to OA and then up from A to K. So what would that mean? I'm going to do OA to AK. Again, we got OA, which is A, but we don't have AK. Oh my goodness, this never ends, man. Never ends. Okay, but we can find AB. So let's do that first of all. Let's find AB. Let's give this a nice green color. So AB will be from A to O, and then from O to B. Now that's alright, because that means AB from A to O is in the opposite direction of A, so that's negative A, and from O to B goes to B. Great, and we can swap them around to make it look nice. So minus A plus B or B minus A. So we got AB. Okay, once we got AB, let's write that in. So we got AB. This the whole thing is B minus A. That means K to B is 2/3 B minus A, and AK is 1/3 B minus A. Right, we're making progress. Now we can go back to OK. So now we can get this vector. OK, remember, is OA. OA, so that is A. And AK, we just worked that out. AK is there. 1/3 B minus A. So let's simplify that. That means A, multiply the brackets, that's 1/3 B minus 1/3 A. Okay. So A, imagine that's 1A. 1 minus 1/3 is 2/3 A and 1/3 B. Sweet. Now we got OK. Now we can backtrack again to my original equation, which was up there. Remember, this is what we were going for. We were going for OK plus KL. So we're back over here. We want to know what's the position vector of L. So that's OL. So we just need to put OK in there, which was 2/3 A plus 1/3 B, which we worked out down here. Okay, so last thing to do is add the A's together. Again, this is 1. So 1 plus 2/3. If you forgot what it is, how to do, just do it in a calculator. Say for 1 plus 2/3, of course, and you'll get 5/3. So we add the A's together. That gives us 5/3A plus that third B. And we've done it. Big tip here, and it really helps in the exam to get you marks if you're confused. You see what I've done here, writing down the paths in terms of the letters. That can get you marks. Even if you make mistakes later on, you get confused. Writing down the paths you've got to follow in terms of the capital letters is a very good idea to help you score marks. And you're going to do it. Question 27, we got a line x plus y equals x plus 1 and a quadratic graph. So let's see what that looks like. Okay, so here we go. First of all, we've got the line y equals x plus 1. There it is. And that intersects, which means it crosses the y equals x squared minus 3x minus 11. See? And they intersect, they touch each other in these points. There's the 1 point, 6, 7, and there's the other point, minus 2, minus 1. And that's the answer. 6, 7, minus 2, minus 1. In the exam, of course, you don't have Desmos graphing, you don't have the internet, so we need to do this algebraically. So let me show you how we're going to do that. First of all, we got x plus 1 equals to y, and all of this is also equal to y, so that means they equal each other. Of course, where they cross, they are equal. So we can write them as equal to each other. So x plus 1 equals x squared minus 3x minus 11. Okay. Now he's going to rearrange it to set it equal to 0, which means we need to subtract the x and we subtract the 1. So we subtract the x, we subtract the 1. Meaning over here we'll have 0, and there we have minus 3x minus 1x is minus 4x, minus 11 minus 1 is minus 12. Okay, recognize quadratic equation. We need to factorize two brackets because we have two answers as well. So 0 will equal x. First, we need to think of two numbers we multiply together to give me minus 12. Okay, first thing that springs to mind is 3 times 4. 3 times 4 is 12. One of them has to be negative. The minus 4 is bigger, that's minus 4, whereas 3 minus 4 is minus 1. Now remember, when we add them together, we need to get minus 4, we get minus 1, so this is not working. This is not good. Okay, we think of other two numbers multiplied together to give us minus 12. What about 2 and 6? 2 times 6 gives us 12. Okay, one of them has to be negative because it's minus 12. You see there's a minus there, so probably the biggest one is negative, because then if I add them together, 2 plus minus 6 gives me minus 4. Brilliant. You see that? Minus 12 minus 4 minus 12 minus 4. I found my two factors. It's a positive 2 and a negative 6. Right. Now, split them up, set them each equal to 0. So we get x plus 2 equals 0. That means x equals minus 2. And we got x minus 6 equal to 0. That means x equals 6. Brilliant. We now have our x values, minus 2 and 6. We just need to find our y values. To do that, we can use any of these equations at the top. This one or that one, or both. Of course, the first one is a lot easier. Okay, so here, y equals x plus 1 is the equation of the line. We put the negative 2 where the x is. That gives us minus 2 plus 1 is minus 1. So when x is minus 2, y is minus 1. The other one, the same. Put the 6 where the x is. So y equals 7. We've done it. Okay, if you've got time, substitute them into that second equation as well. See if you get the same answer. You should. Okay. Or if you've got decimals graphing, which you shouldn't. There's the answer. 6, 7 minus 2 minus 1. And you've done it. Excellent. That's it for today. I hope you enjoyed it as much as I did. I hope you found it helpful. Please like, please subscribe, and give me some comments in the comment section. See you again soon.